All right, let's go ahead and now talk about electromagnetic radiation. Electromagnetic radiation, also known as EMR, are a series of waves that have different energies. Okay, so they have different energy. And there's so what we're going to talk about is what the electromagnetic spectrum is, which before we fill out these notes, I'm going to go ahead and go to this right here. This right here is the electromagnetic spectrum, and you can see that radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays, those are all part of the electromagnetic spectrum. We happen to be able to see a very small part of the electromagnetic spectrum. It's visible light. So whenever we see red, green, blue, yellow, or whatever, we're seeing a part of the electromagnetic spectrum. Now, again, we only see a very small part. In fact, it's so small that this actually is too large of a range that it's showing. It's actually a very small sliver of the electromagnetic spectrum that we can see. And you'll see that radio waves are the same thing as visible light. Gamma rays are the same thing as visible light. So are X-rays and microwaves and all that. They're all the same thing. They just have different energies. Now, let's go ahead and talk about the different parts of a wave. The crest is the high point on a wave. The trough is the low point. And the distance from any point on the wave to the next adjacent point is called the wavelength. So for example, from here to here is the wavelength. From here to here is the wavelength. From here to here is the wavelength. And so those are all have the same length. The way I think about it is, if you choose a point, any point, let's go ahead and say I choose this point. When does the wave start to repeat itself? Okay, it starts to repeat itself right here. And this would be the wavelength. So it's the length that it takes the wave to start repeating itself. All right, so let's go ahead and talk about these different variables here. We have the first one is wavelength. And that is the length of one wave. Then we have what is called frequency. Frequency is going to be how often the wave passes a point in 1 second. If you were to imagine these two right here traveling at the same speed, and if they're traveling at the same speed through space, this one would end up having a high frequency because there's a lot of waves passing a point in a given second. This one's going to have a low frequency because there's not as many waves. And then we have energy. And energy is defined as the ability to do work, but what we're going to do is we're going to think about the energy of a photon of light. All right, so imagine you're doing this with a person, or doing this. So imagine you're doing those two different things. Which one will require more energy, the first one or the second one? Well, the first one would require more energy, and so this is going to be high energy, and it's going to be low energy. Notice how this is the one that has the greater frequency. So greater frequency means high energy. This one has a lower frequency is low energy. Now, notice here, this is high frequency, this is low frequency. But what about their wavelength? Well, this is a larger wavelength than this. And so notice how when you make wavelength larger, so when you increase wavelength, frequency goes down, and when you make wavelength smaller, frequency goes up. So wavelength and frequency have a direct relationship. That means when wavelength increases, frequency decreases. Or when wavelength decreases, frequency increases. So when one goes up, the other one goes down. And I'm really sorry, it's not direct, it's indirect. It's indirect. And I want you to write underneath this inversely. They are inversely related. Now, energy and frequency. Notice how this is high energy, high frequency. Those are direct, which means when one goes up, the other one goes up, or when one goes down, the other one goes down. And then energy and wavelength are indirect, which means when you increase the wavelength, you're decreasing the energy, or when you decrease the wavelength to make the wavelength smaller, you're increasing the energy. All right, so let's go ahead and do something real quick. What are the colors in the rainbow? Well, it's Roy G. Biv. That's how you remember, Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. Notice how violet has a smaller wavelength, which means it has a higher frequency and a higher energy. And so notice how this right here is representing this small part of the electromagnetic spectrum. And so if you take a look, this is a large wavelength, small frequency, small energy. This is a small wavelength, large frequency, and large energy. All right. So let's go ahead and answer these questions here. Again, this is going to be Roy G. Biv. Which has a higher energy, UV or X-ray? Okay, so we have ultraviolet and X-ray. Which one has a higher energy? Well, again, we have energy increases this way. So energy increases that way, so the one with the higher energy is going to be X-ray. All right. Which one has a lower frequency between X-ray and gamma ray? Okay, so we have X-ray and gamma ray. Which one's a lower frequency? Well, notice how this is high frequency here. So if this is high frequency, then X-rays are going to have a lower frequency. So that one is lower. All right, next one. Let's go ahead and look at visible light. So which has the shorter wavelength, visible or microwave? Okay, so here's visible, here's microwave. Which one has a shorter wavelength? Well, this is a larger wavelength right here. And so that means that microwave will have a, visible light will have a shorter wavelength. And then which has the lower energy? Which one has a lower energy between blue and yellow? Well, here's blue, here's yellow. Again, energy increases going to the right. And so that means that yellow is going to have a lower energy. Blue will have a higher energy. And that's all you need to know for electromagnetic radiation. Go ahead and watch your excited state electron configuration and come prepared to class with some questions. Have a great day.